Hi, my name is Erica Pagan, and you're about to learn a lot. Oh, hey Anthony, what's going on?
Nothing, just dancing.
Oh, that's cool. So, how have you been?
Good. Oh, hello everybody. My name is Anthony Pagan, and I have a question.
Oh,
for
what
you,
is it?
Erica.
What is it?
What's a radio wave?
Well, looks like you're in luck, little guy. We're about to find out.
Radio Waves 101.
Hello, thank you for watching News 7, and here's Kylie Gorney with the story.
Radio waves. What are they and what is the history behind them? I'm Kylie Gorney and I'm here to teach you all about radio waves. Radio waves are a type of electromagnetic radiation with wavelengths in the electromagnetic spectrum longer than infrared light. Radio waves have frequencies from 300 gigahertz to as low as 3 kilohertz and the corresponding wavelengths ranging from 1 millimeter to 100 kilometers. Like all electromagnetic waves, they travel at the speed of light. Hello, I'm back. This man is Guglielmo Marconi. He pioneered wireless work in the late 1800s that would help more than 20 years later to determine which wavelengths would be available for broadcasting. Marconi's most significant early discovery was the ground wave radio signal. This made long-range signaling using electromagnetic radiation practical for the first time. Like light, it was believed to normally travel through the air in a straight line until absorbed or reflected. What Marconi stumbled across was that for longer wavelengths with a properly constructed antenna, some of the radio waves, instead of just going through space, actually traveled along the ground and following the contour of the Earth. Thus, the Earth could be used as a guide, carrying signals over the horizon to distant points. Moreover, it turned out that the ocean was a better conductor than soil for transporting radio waves to distant points. It was found that the longer the radio waves, the better the Earth acted as a conductor, and the greater the range for a transmission of a given power. For this and other early work, Marconi shared the 1909 Nobel Prize for Physics, and for 25 years following his pioneering work, the ground wave signal was the most important factor in determining the desirability of a given radio wave. That's all from Kylie Gorney.
Thanks, Kylie, and thank you for watching News 7. See you next week. And welcome back to Family Feud! Today we have the Smith family.
Yeah,
Sally
alright.
Smith.
Alright, honey, yeah.
And Bill Smith.
Hey, alright.
And over here we have the Jones family. Celinda. And Bob. Alright, first we're going to get the men of each family to step up. Come on, Bill. Come on, Bob. Here we go. Alright, top 4 answers are on the board. The question is, what is an interesting fact about a radio electromagnetic waves? Go, Bob, go!
Radio waves can travel through concrete, brick, and wood.
That's correct!
Hey!
Alright, looks like this one's going to go to the Jones family. Okay, so Linda, are you ready? What is an interesting fact about radio waves?
They're square.
Oh, I'm sorry.
Yeah,
That's not
alright,
correct.
yeah.
Alright, looks like it's going over to the Smith family.
Alright,
The
yeah.
first question is for Sally. What is an interesting fact about radio waves?
Radio waves can't travel through electric conductors.
Alright, looks like Sally got it. Going on to you, Bill.
All
What
right.
is an interesting fact about radio waves?
Let me see. Radio waves have the longest wavelength in the electromagnetic spectrum. Yeah!
Alright,
Alright!
last answer on the board. It's up to you, Sally. Here we go. What is an interesting fact about radio waves? For the winner, here we go.
Anything that gives off some sort of warmth can form a radio wave.
Yeah!
It looks like the Smith family
Yeah,
got it.
alright, yeah.
It was a good fight. And thank you for watching Family Feud.
Yeah!
What are the uses of radio waves, you ask? Well, let me tell you. Today I'm going to take you on a journey through time to see the uses of radio waves. Are you ready? So, the uses of radio waves include... Oh my goodness! I I am so sorry. Would you look at that? A radio. One of the many uses of radio waves. To be continued. Earlier we addressed that we were gonna find out what the uses of radio waves were. Well, right now I'm about to go interview the general public to see what they think the uses of radio waves are. Here we go. Hello, sir. What do you think the use of radio waves is?
I believe radio waves help in tracking planes with radar. If radar gets sent out using radio waves to track airplanes in the air.
Okay, thank you. Have a good day.
You too.
Sir, what do you think the use of radio waves is?
I believe the use of radio waves is something that's transmitted through the air, through the sky, through electrical currents or something that transmit waves from one point to another point, which actually gives you and creates the waves.
Okay, thank you.
Yes.
What is the use of radio waves?
I think it's good for information for us. It's that's all I can say.
Okay.
So is that it?
Yeah.
I think it's good for you. Okay. Thank you.
Thank you. It seems like the general public has a decent idea of what radio waves are used for. And yes, those were random people at the park by my house. So yeah. Anyway, are you ready to learn the real use of radio waves? Well, tune in to find out. Before I enlighten you on the uses of radio waves, don't worry, it's coming soon. We're going to do a little experiment. Are you smarter than a turtle? Sir, do you know the uses of radio waves? The answer is yes, the general public is smarter than a turtle. Besides being used for transmitting sound and television signals, radio is used for the transmission of data in coded form. In the form of radar, it is used for also sending out signals and picking up the reflections from objects in their path. The man earlier mentioned something about radar, so he was right. And long-range radio signals enable astronauts to communicate with the Earth from the moon and carry information from space probes as they travel to distant planets. So, radio waves can be transmitted from one place to another through non-conducting materials such as air and space. So that's why they don't need wires. For navigation in ships and aircraft, the radio range, radio compass, and radio time signals are widely used. Radio signals sent from global positioning satellites can also be used by special receivers for a precise indication of position. Digital radio, both satellite and terrestrial, provides improved audio clarity and volume. Various remote control devices, including rocket and artificial satellite operation systems and automatic valves and pipelines, are activated by radio signals. The development of the transistor and other microelectronic devices led to the development of the portable transmitters and receivers. Cellular and cordless telephones are actually radio transceivers. Most telephone calls routinely are relayed by radio rather than by wires. Some are sent via radio to relay satellites. Some celestial bodies or interstellar gases emit relatively strong radio waves that are observed with radio telescopes composed of very sensitive receivers in large directions. So Maddie, next time you're calling Bay, remember that your conversation on your telephone is being relayed through non-conducting materials and radio waves and not through wires.
Hi there. My name is Jordan Bertrand. I'm here at this desk tonight, toiling my night away for you. You see, my vast knowledge of physics concepts and my strenuous work in all of the practice problem novels has led me to a greater understanding of the field of physics, specifically in radio waves. Now, what I have done for you is devise not one but two problems for us to work together to solve. Now, let's take a look at that first problem. So, here we are, looking at the first problem. I'll just go ahead and read it for you. The radio station, KUSC, in South California, broadcast at 91.5 megahertz. Now, what I want you to do is calculate its wavelength in meters. During that brief pause that you were unaware of, I went ahead and wrote down some of the constants we'll be using, along with our first step. So what we must do first is convert these megahertz into seconds. In order to do that, we're going to do this. 91.5 megahertz is going to be equivalent to 91.5 times 10 to the 6. Once we do this math, we'll be able to find, hold on, wait for it. Yes, yes. 91.5, multiply that by whatever, 10 to the 6. That's a 6. Yes. What are we going to get? What are we going to get? What do you think we're going to get? It's going to be what? So, that is equivalent. If you want to count the zeros, you can. I really don't mind. There are a couple of them. It's 91.5 times 10 to the 7. Boom. So this is us in seconds. Very nice. Now what we're going to do is go ahead and move on to step 2. Step 2 is signified by this simple little 2 I drew. What we're going to do here is use the formula wavelength times velocity equals our constant c, which is the speed of light. We're using that because that's basically the same thing as this one right here. Yeah. So, what do we know? What do we know? What do we know? Well, what we don't know is our wavelength, because we're trying to find this. Right? Right. So, we're just going to put an X for that. Nice. Now what we do know, what we just found right here, is our speed in seconds. So we're going to do 9.15 by 10 to the 7 seconds, -1, boom, boom, and we know that that equals our constant, which is just simply 3.0. God, filming is so hard. I'll tell you that right now. Like, how do you write and film? It's ridiculous. Meters per second. Okay. So, basic math right here. We're just going to divide that. And we're going to end up with, let's see, 915. Oh my goodness. 10 to the 7. Thanks to our handy-dandy calculator, math is made fun and easy. So to solve the problem, we're simply going to type in our constant, and we're going to divide that by the speed we found. And what we get will simply be our wavelength in meters. So 3.278, and we're going to go ahead and round that up to 3.28. So that means our X is 3.28 meters. I will now go ahead and read the second question to you. A low-frequency radio wave has a frequency of 250,000 Hertz. Now what I want you to do with this information is find the wavelength of this radio wave. And just as a hint, I don't want you to forget that this is an electromagnetic wave, and therefore you should automatically know its speed. Using that very helpful hint I gave you, we can take a look at our handy-dandy pre-AP physics equations. I'm just going to flip the page and we're going to go over here. Unit 5, waves. Okay. Oh, here we are. C equals 3.0 by 10 to the 8. So that's simply the speed of light, which is the exact same as the speed of an electromagnetic wave. So what we're going to do with this information right here is write it right here. 3.0 to 10 to the 8. So we know that this is the speed of our electromagnetic wave. Now the formula we're going to use is also in our handy dandy formula chart. And it's going to be this second one right here, C equals wavelength times frequency. So that's simply this constant equals wavelength times our frequency. Now what we have is our frequency. That is right here. What we don't have is our wavelength. So in order to get our wavelength, we're going to divide our frequency over here and divide our frequency over here. So what we're going to do is get our handy dandy calculator. We're going to turn it on. Now what we do once we turn it on is type in these numbers. So we're going to type in 3.0 by 10 to the 8, and remember that this is just our speed of the electromagnetic wave. And we're going to divide that by our given frequency, which is 250,000 hertz. And what number are we going to get that will equal our wavelength? 1200. That is the answer. It's 1200. So we simply take this answer and we're going to go ahead and write it down, because that is the only way to solve a problem is by actually writing it down. So wavelength equals 1200. Very nice. And we're not going to put a unit of measure because no unit of measure was indicated in the problem. You're welcome, you know? I mean, it's as simple as that. I hope you all learned something out of this time we spent together. I mean, you're welcome.
Strippers.
Mike Wilmer.
Bands that make her dance. 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 All these chicks